In this lesson, we're going to talk about arithmetic sequences and series. So the first definition we have, it says, an arithmetic sequence is a sequence in which each term after the first term differs from the preceding term by a constant amount. And then it specifies the difference between consecutive terms is called the common difference. I want to look at this example. It says, is the sequence an arithmetic sequence? If so, what is the common difference? So let's look at part A. It goes 2, 6, 10, 14, 18. To get from 2 to 6, you're adding 4. To get from 6 to 10, you're also adding 4. And then it continues in that pattern. So this is an arithmetic sequence. And then it says, if so, what is the common difference? So our common difference, we use the letter D, and your common difference is 4. If you ever are having trouble finding the value of the common difference, and we're going to talk about this in just a second, but pretty much you take one term and you subtract the term before it, and that will kick out your common difference. And again, if I take 10 and subtract the term before it, it's giving me that same common difference. For part B, you're going from 2 to 5 to 10 to 17. So to get from 2 to 5, you're adding 3. To get from 5 to 10, you're adding 5. To get from 10 to 17, you're adding 7. Since we're adding a different value each time to get to the next term, this will not be an arithmetic sequence. It says, note, your common difference can be given to you as D equals A sub n minus A sub n minus 1. You're taking a term and you're subtracting the term before it, and that will give you that common difference. Next, if you have a couple of terms in a row, like in that last problem where we had 2, 6, 10, let me pull this back up here. So in this problem, this is your first term, we'll call it A sub 1. 6 is going to be your A sub 2, 10 is your A sub 3, 14 is A sub 4, this would be your A sub 5. And if I wanted to find out what A sub 6 is, we would just add our common difference of 4 and get that next value of 22. But if I wanted to find A sub 15, again, you could still keep adding 4 each time and finally get to A sub 15. But if you were ever asked, what is A sub 227, you probably won't want to keep adding 4 every time. So we have a formula for that. So here's the formula for the nth term of an arithmetic sequence. It says A sub n equals A sub g plus the quantity n minus g times d. And just a heads up, in some textbooks, most textbooks, you'll see this part as A sub 1, which is just the first term. And so we've made it a little bit more generic by labeling it A sub g. And A sub g, we're calling it the first term you're actually given. A sub n is going to represent the last term that you have, and d is your common difference. So this formula will help us find any given term that we need. So here's an example. Find the 9th term of the arithmetic sequence whose first term is 6 and whose common difference is -5. So what I like to do is create a chart. So I'm going to say A sub n, A sub g, n, g, and d. For A sub n, we're trying to find the 9th term. So we're going to label that A sub 9. A sub g would be, again, the first term that you're given. So it says first term is 6. So that would be an A sub 1, and it's equal to the value 6. And your common difference is -5, so we're going to plug in a -5 for d. And if you'll look right here, it says A sub n and A sub 9. We're going to let n equal 9. Same thing here, A sub g, first term you're given is going to be A sub 1, so we're going to let g equal 1. And then we're going to plug all of these values into this formula. A sub n equals A sub g plus the quantity n minus g times d. So a sub 9 equals a sub g, or a sub 1, plus n is 9, g is 1, and that common difference is negative 5. So finally I'm going to plug in a sub 1 is 6, and you can do that a step earlier if you'd like. So a sub 9 is going to be 6 minus 40. This next example says, according to the U.S. Census Bureau, new one-family houses sold for an average of $159,000 back in 1995. Oh, that's nice. This average sales price has increased by approximately $9,700 per year. Part A, write a formula for the nth term of the arithmetic sequence that describes the average cost of new one-family houses n years after 1994. So we're going to start with that same chart, a sub n, a sub g, n, g, and d. First, because we're just trying to find a formula for the nth term, I'm going to put a little slash through a sub n and n because that's going to be our variable, so we're not going to plug in a value for those just yet. The first term we're given would be, let's see, right here, according to the U.S. Census Bureau, new one-family houses sold for an average of $159,000 in 1995. So because this says the average cost of new one-family houses n years after 1994, that would put us at 1 year after. So it's going to be a sub 1 is $159,000. Therefore, a sub g, a sub 1, that means g is equal to 1, so we're going to plug in 1 for g. And this average sales price has increased by approximately $9,700 per year. Because we're adding $9,700 each year, that's going to be our common difference. So now we're going to take that information, we're going to plug it into that same formula, a sub n equals a sub g plus the quantity n minus g times d. So a sub n is equal to a sub 1. And then because we're leaving n as a variable, I'm just going to write n minus g is 1, and d is 9,700. We're given a sub 1, so we're going to plug in 159,000. I'm going to distribute this 9,700 and finally combine like terms, and we have a formula for the nth term of the arithmetic sequence. And then I have 159,000 minus 9,700. So we have plus 149,300. Part B says, how much will new one-family houses cost on average by the year 2010? So what we want to do, since we have that formula, a sub n is equal to 9,700 n plus 149,300. We just need to figure out what our n is going to be in the year 2010, and that's given the fact that this formula is going to represent how many years after 1994. And so you end up getting 16 years after 1994 will be the year 2010. And that's a value we're going to plug into our formula. So a sub 16 is equal to 9,700 times 16 plus 149,300. 155,200. And then finally add those together and we get a sub 16 is 304,500. And that's the cost of new one-family houses on average in the year 2010. This example says write a formula for the general term, nth term, of the given arithmetic sequence. So it's going 6, then 1, then -4, then -9. So we're going to set up that same chart, a sub n, a sub g, n, g, and d. So because it wants a formula for the general term or the nth term, we're going to put little marks through a sub n and n to keep those as variables. A sub g is the first term you're given. So if you look at your sequence, you have 6. G is going to be 1. And then we need that common difference. So you're looking back to your sequence and you're saying 6 plus what gives you to 1? 1 plus what gets you to -4? -4 plus what value gets you to -9? So each time we are adding a -5. If that doesn't make sense, you can always take one term and subtract the term before it. And then you can see that that's going to give you -5 as your common difference. Okay, let's go ahead and plug everything into the same formula. I'm going to leave a sub n and n as our variables and plug everything else in. And then one last step where we plug the a sub 1 in as 6. And at this point, distribute and combine like terms. So the formula for the general term is going to be a sub n equals -5 times n plus 11. In this example, it says given a sub n equals a sub n minus 1 plus 5, and also given that a sub 1 is 6, write a formula for the nth term of the arithmetic sequence, and it says as a hint, don't use a recursive formula. So again, we're trying to find that nth term of an arithmetic sequence with this given information, and then once we find that, then we'll use it to find the 20th term. So since we're going to need an nth term of an arithmetic sequence, I'll start that same chart. Go ahead and block out your a sub n and n. The first term you're given is still a sub 1, or the value 6. Therefore, g is 1. And if we go back and read this notation, it's saying a sub n is equal to a sub n minus 1, which is essentially the term before this one. And then you're adding 5. So just by looking at this right here, it's telling you what your common difference is. You're taking a preceding term, adding 5, and getting the next term. So same formula, a sub n equals a sub g plus the quantity n minus g times d. Plug everything in. And finally, distribute combine like terms. So this is going to be 5n and then minus 5, and then we're adding 6. So there's your formula for the nth term of the arithmetic sequence. And then now that we have that, we're going to use it to find a sub 20. So a sub 20, and it's really convenient. You're just going to plug in 20 for n. So a sub 20 is 101. Our previous problems have been dealing with sequences, and then now we're going to look at a series or a sum where you're adding up all the terms of the sequence. So we have this definition. The sum S sub n of the first n terms of an arithmetic sequence is given by this formula right here. So box, highlight it, save it. S sub n is equal to n divided by 2 times the quantity a sub 1 plus a sub n, where n is going to be the number of terms of the sum or the sequence that you're adding up. I just want to make a note to stay consistent with the previous part of our lesson. You can also refer to this as a sub g, the first term you're given. This example says find the sum of the first 15 terms of the arithmetic sequence, 3, 6, 9, and so on. So to find the sum, again, you're using this formula. So if we make a chart, we're going to include n, a sub 1, a sub n. Because it says it's 15 terms, that's going to be your n. And a sub 1 is the first term you're given, so that's 3. But we don't have a sub 15, because that would mean, again, going from 3 to 6 to 9, you'd add 3, you'd keep going until you had 15 terms. We technically could do that, but instead I want to practice what we've been doing in this lesson. So we're going to look at another chart. So a sub n, a sub g, n, g, d. We want to find a sub 15. The first term you're given is a sub 1 or 3. N is going to be 15. G is going to be 1. And then you can look at this and go 3 plus what is 6, 6 plus what is 9. Each time you're adding a value of 3. So that's going to be your common difference. Do I have room right here? A sub 15 is a sub 1 plus, oh boy, that's not going to fit. Let's move this down here. A sub 15 is a sub 1 plus the quantity n minus g times that common difference. So we get 3 plus 14 times 3, 30, 42. So a sub 15 is going to be 45. So now we can go over a sub n, or a sub 15 is the value 45, and now we can use our sum of the first 15 terms. So it's going to be 15 divided by 2 times the quantity a1, which is 3, plus a sub n, which is 45. And usually these problems are rigged in that you won't get a fraction, something will reduce. So either this value will reduce by 2 or the sum in here will reduce by 2. So 5, what does that make? 48. And again, these will reduce here. And we're just multiplying 15 times 24. So what do I have? 360. This example says find the following sum. And we have sigma notation. On the bottom it says I equals 1, and on top we're going to have a 30. And the formula is 6i minus 11. So to find this sum, we're going to use the same formula, or the same chart. S sub n is n divided by 2 times a sub 1 plus a sub n. So we need n, a sub 1, and a sub n. If you look at this, because it's in sigma notation, it starts at 1 and stops at 30, so that means there's going to be 30 terms. So that means this is a sub 30. This is still a sub 1. To find a sub 1, it's super convenient because you have 1 down here. You can just plug in 1 for I, and you end up getting 6 minus 11, or negative 5. And then for a sub 30, again, very convenient because you have your formula right here. You're going to plug in 30. So this makes 180 minus 11, or we get 169. So now we can use our sum formula. S sub 30 is 30 divided by 2 times the quantity negative 5 plus 169. So right here, 30 and 2 reduce, And then you have 164. And 15 times 164, I have 2,460. So that's going to be the sum of this sigma notation. This example says, an elderly person has assets of $350,000. One option that they are considering is nursing home care for a 6-year period beginning in 2001. The model A sub n equals 1,800n plus 49,730 describes yearly nursing home costs n years after 2000. Identify whether or not the person will have enough money to pay for the facility. So a couple of things. We have one option that they are considering is nursing home care for a 6-year period, and it says it's beginning in 2001. So we are going to find S sub 6. So we have n, a sub 1, a sub n. So n is the number of terms, so there's going to be 6 of them. To find a sub 1, we're going to plug that into this formula that's given for a sub n. And then a sub n is going to be plugging in 6 to the formula. When you work this out, you get 51,530. To find S sub 6, we're going to use the same formula. N divided by 2 times the quantity a sub 1 plus a sub n. A sub 1 is 51,530. A sub n is 60,530. So if we add these together, we get 3 on the outside, 112,060. Multiply that together, and what did I get? 336,000, let's see, 180. So let's check this. That amount is going to be less than 350,000. Therefore, the person has enough to pay for the facility.
Peace up, A-Town down. Yeah, yeah. Okay. Let's go.